Hello, this is Hui. Welcome to watch my video C++ programming on Linux. In previous video, we have discussed the concept of TLS SSL non-blocking model. The example of that video, we have updated OpenSSL TLS blocking client to OpenSSL TLS non-blocking client. In this short video, it will continue discuss TLS SSL non-blocking concept using another TLS SSL security library, WolfSSL, a library focused on embedded API and devices. The benefit of non-blocking TLS concept is improved performance, suitable for resource-constrained environment, flexibility in I/O and threading models. WolfSSL menu on WolfSSL document website has more details information. It's an excellent and comprehensive resource and a great reference for starting to integrate WolfSSL into various environments and a detailed description of functions and structures. The WolfSSL embedded SSL TLS library can easily be integrated into your existing application or device, provide enhanced communication security through additional SSL and TLS. Here, our Linux, the platform we're going to program on is Ubuntu 24.04.2 LTS. In previous OpenSSL video, we have created two C++ programs example, OpenSSL TLS client and OpenSSL TLS server.cpp. The OpenSSL TLS client.cpp is a blocking model TLS client C++ example, and the OpenSSL TLS server.cpp is a basic echo server examples. In another video, we have upgrade OpenSSL TLS server to WolfSSL TLS server. In this short video, we are going first convert the OpenSSL client.cpp to a WolfSSL TLS client.cpp and then update the WolfSSL TLS.cpp from block model to no block model. We are going to create a new program, WolfSSL TLS client.cpp, and we are going to import from OpenSSL TLS client.cpp r OpenSSL TLS client.cpp. First, we are going to update header file. We delete this two OpenSSL header file, 2dd. The usage will not change. Argument 1 is the host or URL. Argument 2 will be the port number. And using function get host by name to resolve the host name. Using socket function to create socket FD. And then we connect the socket using connect function. Next, initialize the WolfSSL environment. Declare WolfSSL context and the WolfSSL object. The WolfSSL CTX structure, WolfSSL context, contains glob value for each SSL connection, including certificate information. To create a new WolfSSL CTX using function WolfSSL CTX new, this function requires an argument which defines the SSL or TLS protocol for the client or server to use. Here is a possible method for TLS client, and here is a method for DTLS client. In this short video, we are going to use this method, WolfSSL v23 client method, which uses the highest version possible from SSL 3.0 to TLS 1.3. Back to our editor. Delete this line. If CTX is none, print out debug message. WolfSSL CTX new function could not initialize the WolfSSL context. Next step, create and initialize WolfSSL object. Copy this for line for YY, paste here. SSL pointer is none. Print error message. WolfSSL new function could not initialize the WolfSSL object. Next step, attach WolfSSL object to the socket. First, declare some variable, return code RET, error code ERR, and a memory buffer. The function of attach WolfSSL to the socket is WolfSSL set FD. If return code is not equal WolfSSL success, it means error. Using WolfSSL getError function to get an error code. Print the debug message for error. And using WolfSSL ERR error string to get the error description. Next step, connect and initialize handshake. Function WolfSSL connect, parameter is SSL. Copy this 1, 2, 3, 4, 5 line, 5 YY. If return code is not a WolfSSL success, we use a function WolfSSL getError to get error code and print a debug message error descriptions. Delete this for line for DD. During handshake processing, WolfSSL by default will perform peer verifications, but this requires the CA certificate. Since this demo we are using self-signed certificate, this process will return the error. So before we doing handshake, we have to reset the connection verification to remove doing client authentication on the servers. Function WolfSSL set verify. This function set the verification method for remote peers and also allow a verification callback to be registered with the SSL session. The verification callback will be called only when verification fail has occurred, and the verification could be verification none, SSL verification peer, and verification fail if no peer certificate. In our demo, Since we use self-signed certification, we just set verification none and remove doing client authentication on the servers. First parameter, SSL. Second parameter is verify none. And the third parameter is the callback function. Since we are not using callback. Next, make a loop. Get a message from console right into the send buffer. If message input is 0, exit from the loop. Now we're going to update SSL write to WolfSSL write. Function WolfSSL write. This function will write size of bytes from the buffer date to the SSL connections. This function return real byte write to the socket, and 0 will be returned upon the failure, and then we can call the function WolfSSL get error to get the specific error code. Back to our editor. If send byte less equal 0, it will be the error. Copy this 2 line to YY. Get error code, print a debug message for the receiving. If received byte greater than 0, it means a success. Else is the error. For success, print out the message received. For error, copy this 2 line to YY. We get the specific error code and print debug error informations. Next will be update the shutdown. Remove this. Delete this line. Close the socket. Free the WolfSSL context object. The last step before exit will be to clean up the WolfSSL environment. Now we have successfully updated OpenSSL TLS client to the WolfSSL TLS client using WolfSSL libraries. We save our program, WQ. Now program has been saved. We compile our program, WolfSSL TLS server, WolfSSL TLS client. Now program has been compiled. This is our executable, Wolf TLS client, Wolf TLS server. Client is a block model TLS client. The server is a basic echo server using WolfSSL library. To test our new created WolfSSL TLS client, we're using 2 terminals. On the top terminal, we're going to run our basic TLS echo server. Bottom terminal, we're going to run the client. The self-signed certificate using our preview video generate WolfSSL server certificate.pem and the WolfSSL server private key. So we start a server. Port number is 1234. Certificate WolfSSL server cert.pem WolfSSL server key.pem. Now our basic echo server has started. Library version is 5.7.4 and listening on the port number 1234. Bottom terminal, we're going to run our client, the host name on the server, and the port number 1234. Client started. First type message. This is Hui test WolfSSL TLS blocking client message 1. Send this to server. You can see our server has received this message and the server reply back client received the message. Now we are successfully updated from OpenSSL TLS client to WolfSSL blocking model TLS client. Next step, we're going to update WolfSSL TLS client.cpp from blocking model to no blocking model. First, copy and backup our client to the WolfSSL TLS blocking client.cpp. Before processing, first we are going to search WolfSSL menu to see if exist function can be used to configure SSL object to no blocking model. Here, function WolfSSL set using no block. This function informs the WolfSSL object that the underlying I/O is no blocking. After a application create a WolfSSL object, if it will be used with a no blocking socket, call WolfSSL set using no blocking on it. This function has two parameters. First parameter is the SSL object, and the second parameter is the no blocking. Set using 1 is specify no blocking, otherwise is 0. Here, the one function WolfSSL get using no block, and this function return 0 underline is blocking, return 1 underline is no blocking. Check the header file. These two functions is just the map of function WolfSSL TLS set using no block. And here is the specification for real function WolfSSL TLS set using no block. So this function informs the WolfSSL TLS object that the underlying UDP I/O is no blocking. So the function WolfSSL set using no block is for TLS object only. For TLS API, WolfSSL doesn't have function set to no blocking model at WolfSSL object level. It requires to be set at socket level, and the system call fcntl is one of useful function to set socket to the no blocking models. System call fcntl manipulate file descriptor. The most popular use of this system call is to set file descriptor read only, write only, or read write. But it also can be used to set no blocking model flag. If the no blocking flag is not enabled, then system call is blocked until the lock is removed or converted to a model that is compatible with the access. If the no blocking flag is enabled, then the system call fails with the error E again. So if system call fail and the error code is E again, then we can come back to retry again. Back to our editor. First, add some header file. And after create a socket before connect, we're going to set this socket using no blocking model. Option is set field, enable no blocking. If return code is -1, it means error. Copy this two line to YY. CNTL function call error Next, resolving address, no change. And since our socket has been set to the no blocking, connecting will be returned immediately, and we have to check the error. So we're using a loop. If a connection return code is -1, then it's an error. We have to check the error code and decide if we're going to retry, fail, and process. In previous video, we have created a function with socket activity. So in order to save in type, we just copy that function here. Function wait socket activities, pass parameter socket and the flag. Flag is 0 for read socket, 1 is for write socket. This function using select system call to monitor socket, waiting until the socket is writable and readable. System call connect can return many errors. In this short video for demo, we'll only handle two types of error, retryable or in progress and already connect error. The error number E again and E would block is retryable error. And the error number E in progress and E already means already connected. Cut this 3 line, 3DD. Rest errors we just consider as a connection error, DD. So for the E again, would block error, it's a retryable error. Call our waiting activity function. First parameter is a socket, sock FD. Second parameter is 0 for read activity and continue. For in progress and already connect error, we just break and the connection success. For the other errors, print out the error description and error code, close the socket, exit with failures. Create and initialize WolfSSL context, no change, and initialize WolfSSL object, no change. And attach WolfSSL to the socket is the same. Remove doing client authentication on the server, set verify, no change. Connect initialize handshake. Since our socket has been converted to the no blocking, so we have to make a loop, check, retry, process, and failure. Do. So we make a loop, do while. First we do wolf connect, and if return code is not WolfSSL success, we're going to check the error code. If the error code is want to read or want to write, then we have to loop retry again. If error code is want to connect, want to write, if error is want connect, want read, and want write, wait socket activity and continue. Else, consider error, print out the error message, error code, delete this 4 line. Now we converted connect activity from the blocking model to no blocking model. Next, we are going to adjust writing and reading activities. First of loop. Inside the loop, using WolfSSL write to write our message to the socket. If send byte equals the message length, if success, print out message length, send bytes, and message send buffers. Otherwise, we call the error get error code. If error code is want read or want write, then it's a retriable error. Else, we just print out the error message. Retry WolfSSL, the error code, and the error string. Wait socket activity 1 for writing and continue retry. Delete this 3 line, 3 dd for reading. If received byte equals send byte, it's a success. Success, WolfSSL read, received byte, send byte, and received message. Else, going to get the error code. If error code is want to read or want to write, going to be retrying. If error code is 0 return, it means completed. The else will be the error. Wake activity and continue. 0 return. Else is the error. Delete this 5 line, 5 dd. The last, adjust WolfSSL shutting down. Cut this line. If return code equal WolfSSL success, print the message and exit from loop. If error is retriable, print the message, retry. If error equals 0, 2yy, copy this 2 line, paste here. Now we have adjust shutting down activities, and then we can finish our program. In order to better demonstrate how TLS non-blocking model works, in previous video OpenSSL TLS non-blocking example, we have created 2 thread functions, one for sending 5 message and one thread function read 5 message. In this example, we try to create 2 functions, thread SSL send and thread SSL read. Thread SSL send is a TLS non-blocking thread function. Loop send 5 message to server. Thread SSL read is a TLS non-blocking thread function. Loop read 5 echo message from server. So in order to save typing time, we just copy from previous videos example and paste here. Same for the thread SSL read function. To add some header file, before shutdown, add using thread to send 5 message and read 5 message. to better demonstrate how the non-blocking TLS connection works. There are many ways to create and use a thread to process sending and receiving message. In today's example, our focus is on the non-blocking socket concept. So we just use a basic STD thread. First thread is SSL send. Second thread, SSL read, ID 4. Now we finished convert WolfSSL TLS block client to no blocking client. So we save our program, WQ. Now program has been compiled. This is our executable Wolf TLS server, Wolf TLS client, no blocking client. To test our example, we are going to use two terminals. On the top terminal, it's going to run our TLS echo server. First argument is the port number 1234. Second argument is a certificate WolfSSL server cert.pem. Third argument is a private key WolfSSL server key.pem. Now our echo server started listening on the port number 1234. Bottom terminal, we are going to run the Wolf TLS client. It is a no blocking TLS client. First argument is host name. Second argument is port number 1234. Now our client connected. We typing, this is Hui test WolfSSL TLS no blocking client message 1. Enter, send this message to the server. Server received the message, echo back, and the client received this message. To enter, here we can see we're using two threads. Thread send ID 1, thread read ID 4. First thread read retrying because no blocking socket want date to be read, and we send the message 0, 1, 2, 3, 4, 5 message. Read thread message 0, first time retrying, read message 2, read message 3. While reading message 4, got a no blocking socket, want date to be read error, goes to retry, and the second time, successful read message. During the shutdown, we got an error, shutdown not done, we're going to retry, and the shutdown success. Here you can see we have successfully tested no blocking model client. Hello, this is Hui. Thanks for watching my video. Wish it is useful, and it's going to be great to have your feedback.